Okay, great. I forgot to start the broadcast, so I'm just going to reiterate. Ollie just went with the stand-up. He said he's at Google doing awesome io.js debugging stuff. Forrest, you're up next.
I am currently working on getting some async listener stuff patched up. Well, actually, I'm mostly just merging patches to async listener for things like promises and some of the other new things in io.js 1 plus. And I'm also getting ready to do a fairly substantial revision of node continuation local storage to streamline it. And whatever we decide to do around the async listener API will probably get folded into that as well.
Cool. Okay, Glenn, go.
Okay, I've been working with LTTNG, and I'm kind of familiarizing myself with all the tracing stuff in core, and I hope to do more work on that. That's me.
Awesome. Krishna, please go.
Hi, I'm working at Strong Loop, and I worked with Bert on the Zones project, and also working on a separate project called Async Tracker, which uses the low-level async listener stuff and tries to put a generic API around it.
Okay, great. Michael, can you go?
Yeah, I'm working at New Relic, and I recently have been doing a little bit of work to support native promises in async listener, and sort of been messing with a lot of those things for a while. So that's me.
Ryan?
I work at StrongLoop with Krishna, and I've been doing mostly code reviews that would be relevant to this stuff, and just getting the node and production stuff.
Sam?
Hey, Michael. I'm Sam Roberts. I work at Strongloop. I work on our node in the Node Ops group. We work with our agent that extracts profiling and transaction tracing and other information from running node applications. And I've worked on promises. Sorry, not promises. Well, I have worked on promises. I've also worked on zones with Bert and Krishna.
Sorry, that was a lot. Steven, you want to go?
Sure. So I work at AppNeta. I'm writing all their node instrumentation stuff, and I'm just at this point basically getting to digging deeper into Node and io.js core, trying to figure out what we don't already have that I can start adding. Looking at stuff like we have like dtrace in there, and there's a PR right now for LTTNG that's like I'm trying to figure out if there's a generic way that we can like expose that stuff and then like let userland make the implementation specific things.
Cool. Okay, Trevor, your turn.
So I'm responsible for most of the code that you guys are having to suffer through. And yeah, that's me.
So quick point, we're at the limit for Hangouts, and Thorsten can't get on. So if somebody wants to volunteer to like just watch on the YouTube rather than be on, then that would be really good.
I can do that.
Okay, all right, cool. Do you have the link to just watch on YouTube?
Yeah, I think so. Yeah.
Here it is. Okay, all right,
Cool.
I'll get on. Thanks. Okay, so I don't want to wait around forever for Thurston, so let's just start. Async wrap. That's the first agenda item. So what kind of stuff can we look at right now, and then I guess what do we want to see in the future? I'll let you take this, Trevor.
Thank you. All right, right now, as we speak, I'm actually writing a in-depth tutorial about how to use what's there, since it's completely undocumented. And that will be, I'm going to post that by end of day, and then I'll just tweet it and whatever. Everybody can use it and be happy. Uh, the reason it was left undocumented in Node was because I wanted to be able to change it in.
What kind of stuff we got right now, and then I guess what do we want to do? I'll let you.
I can barely hear you, man.
Thorsten, you gotta mute.
Hey, what's up? Yeah, I'm muting. Fine.
Okay, keep going, Trevor.
Okay. All right. So what can we do now? There's a lot, and I'm documenting that, and I will post it online and share it with everyone. So more than what can actually go into that document. What more do we want to see? Hit a few things. Proper support for timers. Internally, for performance reasons, timers are actually handled within a JavaScript linked list, and so nothing is notified on the native side on its own. So I have to put in some special hooks to make sure the native side knows that a timer is being created. So right now, like, it only alerts you if, say, a timer app is created, but not for every set timeout that's created. It's a huge gap, and I know that, and I'm working on it. It's on the roadmap. Also, continuation of process.nextTick. In my mind, process.nextTick should mostly be transparent, and so what it'll do is just basically propagate state from one call to the next. And then interception of errors, that was something that was in async listener that was removed so that I could get the patch landed. Basically, if something throws before it hits unhandled exception, if you set up an error handler for that asynchronous stack, it will allow you to handle it there if it hasn't been handled previously by like the event emitter or anything else. Those three things are on the roadmap to be implemented. One thing we need to work with the V8 team with is there's no way to intercept callbacks that are sent to the microtask processor. And so like native implementation, native promises, there's nothing I can do. Technically, calls to promises are asynchronous, but there's nothing I can do about it, and there's no way I can intercept anything that goes on there. There's no way I can propagate state for native promises, right? It completely breaks it. I need to be able to somehow tap into the microtask processor internally before I can do that. We're going to have to work with the V8 team to be able to do that. Until then, native promises are just off the board. And then last thing that's also on the roadmap is provider filters. Currently, if you look at the export of the async wrap process binding, you'll see a bunch of providers, and they were meant for you to be able to pass internally and say, hey, I only actually want my callbacks called for TCP requests, or I only want them called for crypto requests, to allow you to chain together and be like, I want these few things, basically just a bunch of flags to allow you to specify what you want your things called on. That's something else that's also on the roadmap.
Okay, is that roadmap kind of documented, or is it just like
it will be documented. That's everything I'm working on today.
Okay, great. Once that's in, then we can pull Dominic in and collaborate with the V8 team to get the issues with promises resolved. I'm sure that he's going to work.
Yeah, definitely.
Anybody have any other comments or questions about async wrap?
Real quick for everybody, async wrap really is kind of the junction point for the hooks for everything asynchronous tracing and whatnot. What I would like to see is basically everybody just lay out everything they'd like to see in a tracing API or a whatever API of this type, and then I want to be able to implement the hooks in async wrap so that you can make your own userland modules to do that, right? Because too many people want it in too many ways for us to implement any one solid API in io.js.
Okay.
I definitely agree on that. Just trying to keep the actual core stuff as minimal as possible. Just all we really need is enough information to just be able to like identify the origin of a thing, basically. Just link stuff together with our own monkey patching.
Yeah, and like that part's already in there, but there's more stuff. I know, Forrest, you had like maybe that's just a continuation local storage, but some other people want like better asynchronous error handling and stuff like that.
Yeah, there was Andreas Madsen has been filing a bunch of issues related to things that were in async listener and were pulled out to land async wrap. And it kind of shows what the shape of what people are actually trying to use this for. He's just trying to get his long stack trace module working the way he wants it to, I think, as far as I was able to understand his requirements. But he's not the only person who's just kind of trying to figure out how to pull this thing together, and probably needs a little more connective tissue than in async wrap right now.
That kind of takes us to the next agenda item, which is just async listener. So, Trevor, do you want to give us an update on like where that module is and what its state is and everything?
That I have not been thinking about it since I've been trying to wrap up. Like, I want async listener to be able to be implemented in userland, but I am not done with all the necessary hooks in async wrap in order to do that.
And I'm happy to take the async listener module that I have right now and rework it to take advantage of async wrap when we kind of have all that stuff settled out. My main concern with that is to make sure that the use cases of people like Stephen and Michael at New Relic, to ensure that we have something that is sufficient for their tracing needs, but at the same time is minimal enough that it's not going to have an adverse effect on performance at runtime. And Michael Hayes expressed concerns to me at JS Fest in December about the amount of overhead that async listener imposes, and in part that's because the current polyfill does try to implement most of what Trevor came up with back towards the, God, I guess it's the end of 2013 now. And we have to get to a point where we can make sure that that complexity isn't causing problems for downstream consumers like New Relic and AppNeta, and StrongLoop if StrongLoop decided they wanted to use that as well.
So something that I have sort of noticed with async listener that makes it a little bit more difficult or less useful to use is that you get events about when async boundaries are being crossed, but you have no idea what is actually happening. You just know that something has happened. So you basically end up having to rewrap everything again, which basically doubles the performance overhead of anything like async listener, because that by itself isn't enough wrapping to get any useful information out of it.
See, that shouldn't be necessary at all. Like, wrapping anything shouldn't be necessary.
I agree. But
no, I'm saying currently, like with async wrap, it shouldn't be. This is part of the stuff I'm documenting. Is like it will actually hand you the context object or the request object or the handle object that was created for whatever you're doing, and then there are properties you can hook to it that will propagate with the object through its lifetime, and so you can grab the state of that object at any point in time in the future. Anyway, that's all implementation details. Sorry, but a lot of that stuff is already possible and stuff I will be documenting.
Awesome.
So, Trevor, just a quick question. With the async wrap, the way you're doing it right now, when it hands you the handle object or the request object, is that run before the callback or around the callback? How would that work?
There's one that's run as the object's being instantiated, one that's run just before the callback is called, and then one that's run just after the callback is called.
Great, thanks.
Mm-hmm. Anyway, Forrest, great idea. I'd love for you guys to be able to hash that out in userland with the proper hooks, because this is the exact reason why we pulled it from core, right? Is so that it could be iterated on much more quickly.
Right. Yeah, and I think not to get to the next item on the agenda prematurely, but I think the best way to do that is to make sure that async listener ends up with enough of a stakeholder presence that the people who want to hash that out can do that directly without necessarily me being the gatekeeper on that.
Yeah, I mean, so I think like putting all of the work on Trevor is definitely not sustainable. So the more that we can distribute it, the better. I think Trevor, you're talking about doing all this documentation. Do you have any idea when that documentation might be done?
Yeah, by the end of today, like halfway done with it right now.
Oh, great. Okay. So once that's done, I think that we can just sort of like get all of the people together, like it sounds like Forrest and Michael and Krishna that are using this and using those docs, and then all of the kind of user land iteration and questions and stuff they can take on, and we can have Dominic handle the V8 side, and then you can just focus on stuff.
Yeah, I don't know who would be daring enough to dive into the internals with me, but I really hate that I'm like the single point of failure where, like, if somebody tries to implement a new feature or something to the internals, it might explode in fire because nobody else has actually like really looked at that code. So
I
if anybody,
understand it. I understand it well enough to explain it to people, but unfortunately, I think of all the people on this call, I have the least time to spend on this stuff. So I agree. More people need to deep dive on this.
Got
I'm
onboarded
doing a bunch of that over the next week or two.
hit me up on RC wherever you need. I really want to. I'll see when I can find time to write technical docs on how it was implemented.
Yeah. So that's awesome. Okay. All right. You guys can pick up that thread. On to the next agenda item. Racing. Okay, so we touched on this a little bit with the async wrap stuff, and I'm gonna alter the ordering here just a little bit, which is so there's a question about can we have like a unified trace endpoint that we sort of map to dtrace and map to like other tracing engines. And Trevor, you were saying that you kind of want that to be async wrap.
Well, okay, so let's define like tracing. Like basically, you want counters or do you want stack traces? Right, because those two things can be different. Async wrap can give you counters. What it can't do is like what V8 Profiler does, where it like dumps you call stacks and how often they run. What it can do is say this function has run n times.
Glenn, do you want to jump in here on the tracing probes that you put in for Linux?
Yeah, so that's much more profiler based. What I'd like to see is the ability to get full stack traces using a generic library which all the dtrace and LTTNG stuff hooks into. I'd like a nice API which users can use.
So in your current pull request, like you have a bunch of probes added. Are they added like at the exact same point that the dtrace probes are, or
Yeah.
are you connecting this? Okay. So they're just side by side right now.
Yeah, it's the exact same implementation as dtrace's stuff. I wanted to keep it on the same level and not go overly too complex with it.
Can I chime in here for a second?
Yeah.
I'm not entirely clear if we need these dynamic probes added, because I've been doing some work with dtrace, and basically you can trace like everything, right? You can like give it trace every function entry and exit of this process, and what you're gonna get if you actually log out the stack, you're gonna get also JavaScript kind of assembly code, right, generated from JavaScript, and then you can resolve that. So basically, I've been working with that, and I get like I can generate basically stuff you can load into DevTools with that. And the other thing you can do with perf and dtrace is you can do assembling, right? And then if you dump out the stack trace for that, you also get the call stack. So if you do like a 1 millisecond sampler, you pretty much get all the functions that matter to you, because especially regarding performance, because everything that takes longer than a millisecond you probably don't care for. So I'm not entirely sure why we need to add something to Node in order to or to io.js in order to make that happen. I agree that there should be more better tools, and I'm working on that to make it less complicated and more approachable. But I don't know if that has to happen in io.js.
Well, the main problem with relying on dtrace is that it's not accessible in Linux, right?
Well, right. So that's why on Linux you use perf, but then you basically use the same modules that I basically created, and you get the same kind of output. So it works with perf output or dtrace output, and then you can load it into DevTools, into flame graphs, and also into the Chrome tracing. So that's the idea that I was following, basically.
Can I hook up with you and talk to you about doing similar stuff with LTTNG?
Sure, we can do that. Yeah, I'll post my GitHub in here, and then we can hook up over that.
Okay.
So this is, I guess, a good point to have Thorsten do his stand-up. So Thorsten, can you tell us about the work that you've been doing? Like more the work, not just the stuff that you just mentioned, but more of it.
Okay, so yeah, Thorsten worked for NodeSource, TH Lawrence on GitHub. I pasted it since I said I was going to do it, so I might as well do that right now. So basically, I've been looking at system tools that are already available that are pretty awesome and that are there for a long time, like perf and dtrace and ftrace and so on. So basically, what the idea that I had was that whatever Bren Gregg was doing for FlameGraph, where he basically wrote Perl scripts that convert perf output or I think like instruments output to a format that he can load into a FlameGraph. I basically followed that same idea, except I'm converting everything to CPU profile format, so you can load it into Chrome DevTools. And then I made my FlameGraph app be able to load CPU profiles. And then I'm basically took that format and made a converter so you can load it into Chrome tracing. And on top of that, since we now have perf basic prof flag, which allows you to tell V8 to spit out mapping information for assembly addresses to JavaScript symbols, I can also resolve JavaScript. So dtrace, for instance, if you do a stack, or perf, if you do a stack, it will spit out assembly addresses, like just a
Though
memory.
unfortunately, that should be an item you should put in the doc. Is you have once you turn on the map, you can't turn off the map, right? You have to stop the process.
Correct. So this is more. That's correct. And I've mainly been using this for locally troubleshooting performance bottlenecks. Obviously, for production, that's not the ideal solution yet. But yeah, basically the idea is you can look at the node process from the outside, use these amazing tools that have been around for a long time and are very mature, spit out information, resolve the symbols, and then load it into what you use to working with DevTools, flame graphs, and Chrome tracing. That's basically the gist of what I've been doing, including also to be able to debug your node process, also with perf basic prof flag, and then do a backtrace including JavaScript in it. That basically summarizes everything.
There's lots of good one-off debugging stuff in that, but for the purposes of an APM product that wants real-time data, a lot of that stuff is not super useful. Like dtrace and LTTNG, we have the hooks there to dump into those, but the APM products want into those same kind of areas, so my thought was to make some sort of generic system that we can just pipe these events on the native side into, and then have some consumers on the other end that could be dtrace or LTTNG. It could also hook into our own native modules that we can use.
Now, are you talking? I mean, I see it on the more basic level. We just say, here are all the trace points we're going to put in io.js generic tracing point, and then pass it a value, right? And then for whatever system you're compiling to, it will have a defined replace, which will replace it with either dtrace or whatever you're using, right? That would be one, but that's all on the native side in a compile time. Are you talking more things that you can get access to via a JavaScript API?
My thought was more pure native.
Okay.
It may or may not be possible to send the stuff into JavaScript land without horribly screwing with things. But just having something that like I can spin up another thread in my own native module that just
I
connects
don't
to
even
the class if it makes sense.
I don't necessarily mean sending it to JavaScript, but it looks like start listening for and send that data to this file descriptor, right? And then you can just pipe it all out to a file or to memory or whatever, right? Like, because you trigger them in JavaScript doesn't mean you have to send it to JavaScript. But I think for the short term, the idea would be to go through and find where we have all the dtrace and whatever other probe things, and then create a single generic defines that we can place there, and then other headers can replace those with their own ones. And that way, when somebody wants to implement their own tracing things, they could actually just create a new header with the defines replacing for those, instead of going through and having to edit all those different lines of code like you did, right? Does that make sense?
Can someone? I'm still a little bit confused. Like, so let's just say we would have an easy way to resolve assembly memory addresses to JavaScript, right? So basically, you would see entry and exit of any function, including JavaScript, because it would be logged out as assembly addresses in the stack, right? Assuming we had that, why do we have to put static probes?
It's more like the filter. Like, you know how in debug, how you can say like debug child process, debug net, and then you'll only get information for that. You'd have to be able to place in, tell me all file system calls that are coming from the net module.
Okay, but I mean, couldn't a tool filter those out later? I mean,
so deployment is a concern here, and I think Hayes and Steven can probably speak to this better than I can, because they actually have skin in the game. But one of the main preoccupations I had when I was building out Node New Relic was to make sure that we had something that could be basically a zero effort deploy into production environments, which pretty much necessitated having everything that it was in Node New Relic itself being pure JavaScript. And it needed to be able to turn all this stuff on and off at runtime. So whatever we're using, whether it's a static probe point or dynamic tracing or something built into the platform itself, it needs to be something that doesn't bring along with it any sort of heavyweight deployment like implications, and it needs to be something that can be turned on from within the runtime by a single process without forcing you to be able to have access to your production environment. Think of things like Heroku and other like constrained environments where you don't necessarily have access to deploy things into production.
Of course, I totally get that, but I think you're talking about probes that function without an external tool, right? Like basically, I wouldn't have to. We're talking about two different things. One is like putting probes in for external system tools like dtrace or LTDNG, but I think you're talking about just putting hooks in that don't need an external tool to run. Is that correct?
Well, that's a useful distinction to draw, because I think that's actually where the conversation with me and Trevor and TJ Fontaine and Jacob Groundwater started to get pretty complicated when we were talking about this time last year. Where we kind of got to is we had a kind of brainstorming session where we were talking about maybe unifying some of this stuff so that the tracing API that's consumed by something like Node New Relic is actually using the same static probe points and maybe even has some access for defining new dynamic probe points that is more or less identical to what something like perf or dtrace is using. So there's a convergence in there, but there is a distinction between the two.
So it seems like me like the best way to do this is not to try and block any of the tracing work that's going in on like this perfect unified endpoint, but instead to basically get the Linux tracing PR ready and in and accepted and have people use it and figure out what some of the differences might be between dtrace and LLTNG or like whatever the fucking giant acronym is, and possibly other tracing endpoints that we might want to add. And then once we know any differences or hangups,
Very quiet there.
because there's no objections. Okay, I guess we're moving on to the agenda. Okay, so let's talk a little bit about what tools that we can get at now and what kind of stuff that we can do now that we have a modern V8. I know, Thorsten, you've worked on this. I'm sure that Ali here has some things to say, so why don't you guys talk?
Okay, yeah, so latest V8 added a bunch of hooks for you to get information about created code. Like, right, every time some JavaScript was, translated or whatever into assembly, it will emit like a code creation event, and you can get to those in different ways. Like the one way is with the perf basic prof flag, where basically it's already kind of simplified, translated. What you're getting is just a string of the JavaScript function that was basically generated. And but there are way more detailed ways how you can look at that. But however, in that case, you're going to have to walk the heap and kind of deserialize whatever they put there about the code that was created, including you can get to the arguments and so on. And I've been playing with this a little bit. I got this to kind of work on Linux. You can use GDB JIT symbols that are actually generated to show like stack traces in a debugger, including JavaScript. However, on a Mac, I ran into a bunch of problems, and I don't know exactly where the fault is, if it's V8 or if it's LLDB. But basically, the macho objects basically generates the same kind of information that gets generated during compile time, except it does it while it's running the code, and then basically debugger hooks into somewhere to get to that information and treats it the same way. But basically, short end is I couldn't get this to work with LDB out of the box on Mac. Somehow the macho information is not correct or whatever. So that's kind of where we are right now, and that's why I put kind of an intermediate tool in there to make that work right now in a simplified manner. But that's a huge area where people could get involved and try to kind of make that work properly, and maybe interface with the V8 team to make sure that if there's a problem there, that it gets fixed, or maybe with the LLDB team, if there's a problem there, it gets fixed, and then we have a real good way at looking at unified stack traces.
Awesome. Ali, do you want to say anything?
No, not at this point. We're starting to look at how we can get more of the developer tools from Chrome and some of those features available, but we're starting to look at those things now. But don't have anything to report at this point.
Does anybody know what the status is of like Node Inspector working on io.js? Okay. I'll reach out to them and pull them in if we can. Okay. What's the next?
That's a pretty different thing, right? Like Node Inspector is mostly a debugging tool, not a monitoring tool or a tracing tool.
No, well, it was speaking to this newer V8 stuff, right? Because it uses the V8 debugging protocol, which has changed like pretty dramatically, and the newer tools that it's based on also use that newer one. So I think that's part of just porting over those tools.
As far as I know, Michael, like right now, the Node Inspector is still using the debug port to do everything. Even when you're profiling, it actually tells the debugger to tell V8 to start profiling. So everything goes to the debug port. It doesn't use the Blink protocol. There's a protocol for profiling, and which DevTools is basically using. But the Chrome team apparently has put 15 people or so on pulling the DevTools part out of Chromium. So once we have that, it should be much easier to build something that has an entire protocol covered and allows us to pretty much do everything that you can do in DevTools with a browser app, but do it with io.js.
Okay, so we would basically deprecate Node Inspector at that point.
I would think so, yes.
Real quick, I think we should look for in the future is V8 has a lot of additional internal APIs. Here's I just posted crap. I don't know where that post is, so the YouTube viewers can see it. I'll go post it in a comment there. But that just has a bunch of. It just shows how to use a bunch of different internal callbacks to get information about what the process itself is doing. And this type of stuff is super helpful. And I feel like with a little bit more of this, we could dynamically set up log profiling at runtime using V8 itself. I mean, what better way to get information from V8 than through V8, right?
I guess I just want to clarify that because I've been talking with Trevor about this. Basically, the deal is that I was always under the impression that you cannot profile a process from within itself, right? Like you could get JavaScript information because it's V8 running it, and it can give you information about what's happening in the JavaScript world. But basically, what Trevor is trying to do is make, while your node process is running, you can get information about itself. Like it can trace itself even on the C level and C++ level. Which is pretty amazing if that works. And then you wouldn't need any external tools to get tracing information.
Yeah, I think that's kind of my ultimate goal. I don't I don't need like quite the detail that things like dtrace can get you. I more just need to know of like particular points of interest that are just specific to Node or io.js.
Okay, cool. I think that we're good on that item. All right, so Ben wanted us to talk real quick about libuv. So, are there any metrics from libuv that could get exposed that we don't have currently?
I mean, nothing that you can't hook into. Well, okay, that does depend on external tracing. But since libuv is a C API, it's freakishly easy to hook into it from almost anything. And then, to be honest, there's a lot of there are a lot of things libuv does that are completely masked by the user or to the user, and so like they don't know that you need to run TCP bind or whatever to hook up a TCP connection. Instead, all they want to know is that the server was created.
Okay. I guess that answers that. Okay, so the last thing here is that I need to write up a quick charter for the tracing working group. So what I'll do is I'll just take the list of things that we've been talking about so far to JS so that we can keep this rolling. Does anybody have anything they want to add or anything they want to cover that we haven't covered so far?
I just want to, specifically like what I'm seeing here is that there are at least two different major areas, and we should probably split the efforts up, or at least like have, I don't know, because like one is like about integrating system tools with something we can easily use and do it from the outside, basically trace from the outside. The other ones are all about like making Node do it by itself and not having to use any outside tools. And I think these are like very separate concerns and with very separate solutions. So does anyone agree that maybe we should split this up a little bit, or what do others think?
I think that there's a point that like external troubleshooting, performance problem isolation, and whatever is a fairly separate concern from that of APM, which is more about production monitoring of the health of health and performance of an application. And it does seem like as long as we're working together, we're going to be going a little bit across purposes. So maybe we can all be in a single group, but have like alternating meetings to discuss the separate concerns, because I think there's inevitably going to be a certain degree of overlap, especially if we're trying to settle on some fairly fundamental APIs that will be built into io.js itself, which I know is a goal of a whole bunch of us, is to come up with one set of tools that everybody can build their stuff on top of, and figure out the simplest possible way to do that in core, that everything else can be built externally, like either in other tools or by user land modules.
Yeah, I think I agree. Like I do like that we should actually draw a line of separation just for organizational purposes, but I'd like us to all be in the same room when we talk about just to communication between the groups. Real quick before we go, Glenn, so you have that pull request on Linux for Linux tracing. Can you just give us a status update on that, like where it's at?
Yeah, so it's at a stage where it could be pulled in, but I should probably make it more generic for the actual hooks in from the JavaScript level. So what's happening right now is there's dtrace probes available globally, and there's LTT ng probes available globally. And what I'd like to do is have both of those combined into one probe enabled globally. And if that probe is ever called, it will then call the dtrace probe or the LTTNG probe if they're active. So right now, I might need some help with that, but that's what I'm looking at right now.
That's somewhat related to what I'm trying to look at right now, is just consolidating all of those tracing data consumers to just like one basically pipe that we can just push stuff into, and whatever wants to pull data out of it can do that.
I have a one idea here. Like basically, you know that basically all the core modules are in bundled with Node in basically a C++ file, basically in the basically string of the module. Has anyone thought about maybe creating multiple versions of these strings? One with the dtrace probe, one with the LTDNG probe at compile time. So basically, it would just pull. According to a flag, would just pull one or the other, like one without any probe or with LTTNG, and then you wouldn't have any overhead at all if you're not using them.
Roughly, the idea that I have in mind is having all of these basically just macro calls that we can turn on or off in like the native build of io.js itself, and then have like some native, like external native module that can hook in and just like listen to events to a particular class. If the io.js build is like built without these hooks turned on, then it'll just like try and connect to this class, and there'll just be no events from it. So that should mostly have no overhead.
Can I, hopefully I'm not buzzing anyone, but I would love to see code examples of what people would like the API to look like. That would give me a much better feel of like what the breadth of things are, right? In terms of internal APIs, external APIs, whatever they're looking for. Like a strawman pseudo API of like, this is the kind of information I'm going to dump out.
Really good idea.
I don't know where people could put those, but I would love to see a place where people could just start posting what APIs they would like to see. That, I think, in my opinion, that would be the fastest way to converge all these very complex ideas in tracing and whatever.
I'll try and put something together over the next couple days and give you a gist.
That would be great. Let's open a ticket to track these, and then we'll just start posting all of them.
Yeah, sounds good.
I mean, just to be clear about what I was suggesting, again, like if you look in after you build, if you look in out/debug/gen, there's like a native modules.h or something like that, or like something like that. And basically, if we would just add every module like 3 times in 3 different versions, one with dtrace probes, one like we wouldn't have to worry about any overhead. We'd just be basically getting exactly the code we want. We would just have different versions of the modules. So something to think about there. That's kind of like doing a macro in a way, except you hard-coded.
Yeah, and we want to make something that people can write their own instrumentation easier as well.
Okay, I think we're good, and we're all done. Great first meeting, everybody.
Okay, so before we go, Michael, since I'm taking notes, what are the next steps?
Well, Trevor mentioned that tracking issue, right? So who's going to create the tracking issue?
I thought Trevor said he was going to do that.
Yeah, I'm doing that right now.
Oh, awesome. Okay. So we have the tracking issue, and then we can kind of grow that out from there. I think on some of the stuff, like Thorsten and Will Team are probably just going to keep working. Forrest, I guess like you have a to-do, and maybe some of the Strong Loop guys as well. Once Trevor finishes up that documentation, of really pouring into the documentation and updating your modules that are looking at async wrap, to use that, and then working with Trevor to get any more stuff in that you guys need.
Okay.
On the topic of async listener, the thing Forrest has, do we want to like bless that or something like that and get people trying to work on it and solidify it?
I don't know if it's ready to be blessed yet for the exact same reasons that async listener as an API didn't make it into the current versions of io.js and Node. I think it needs a little more baking. I'd like to see a little more. I mean, I know that you've basically baked it into the app meta agent. I'd like to see some of Michael Hayes's concerns get addressed. And see if we can make sure that we come up with the thing that like I would like async listener to eventually become the cornerstone of whatever APM people use to do this stuff, and that may mean that taking bits and pieces from async listener and CLS and creating one thing that's just purpose built for APM. But I don't think it's quite to that point yet. You guys are free to disagree with me on this, but I feel like there's still some more discussion, bike shedding, what have you, to be had around that.
Yeah, I agree that it's maybe not as as just complete and like just featureful as everyone might want it to be. But
it does not enough too much. And I think we still need to find the correct API service for it. Like it needs to be like there needs to be something that does exactly what is, tries to implement faithfully like the most recent but one version of Trevor's API. And there's a lot of stuff in there that I've gotten feedback that it just isn't really needed for a lot of what, say, New Relic is trying to do. And like at the same time, like there's stuff that like Michael was saying where New Relic is wrapping things again on top of what async listener is already doing. And then there's the whole thing that Trevor ran into with emitter listener, with his emitter observer thing. I can't remember what he called it. And the thing that I ended up calling emitter listener, which is like a really grotesque hack. Like EEs also have their own observability. There's just there's more discussion to be had there before I think we're ready to call this done.
Also, like I mean, in terms of official like things, like we want to do that really conservatively. The biggest reason being that as soon as you do that, you cut off a lot of the innovation and alternatives that happen in the ecosystem. So something like needs to be so far ahead and such an obvious win that there's really no value in not. There's no value in not blessing it and not use it. I think Nan is like a really good example of this, right? Where Nan has been, semi blessed or whatever right now, and we're using it as an upgrade path for most of the changes that happen in V8. But it's already at like version 1.6, and it's been around like a couple years, and people have been iterating on it, and it's just emerged as you're kind of best in class in that space. And I would want to see the same kind of process happen with async listener, where other people try out some stuff, but none of it is quite as good, and async listener has just become like, oh yeah, why would you not use this? It would be silly not to before we bless it.
No, Michael, thanks. I absolutely agree. I definitely don't want another domains debacle where it gets put in and then people end up hating it a lot. there's a good reason why async listener was yanked from core. And even though it did take a ton of work to do, it just wasn't what needed to be in there. And so right now, the only thing I'd feel comfortable blessing are the internal hooks that we're allowing end users to use in order to create their own tracing APIs.
I don't suggest like moving it into core, but I do suggest just trying to get more eyes on that particular module, just because it's the only thing in userland that really seems like it's like at least most of the way there.
We can get people on it and interested in it without blessing it. Like, I mean, we can throw it into like the io.js weekly updates and talk about it on Twitter and like get people like interested in poking around at it without saying this is the thing.
Blessing probably just wasn't quite the right word, but yeah, just more attention.
Cool. All right. Are we all good now? I think we're all done.
Before we finish, does anyone have anything to say about my comment about merging the current PR for LTTNG and then the infrastructure for the static trace point hooks to be a separate pull request?
Yeah, I think just merge it and we can figure out a better way to handle them later.
I was just reading through the feedback, and Ben Nordhaus has a couple comments, mainly about like new files and style problems, and then he does have a comment about the duplication, and I think he's urging to reduce that, but he's not. I don't think that he's blocking on it. So
Yeah.
there may need to be like a little bit of work done before it gets merged, but I don't think that the abstraction stuff actually has to be part of that work.
Also, I'm not going to make this a blocker, but empty function calls from JavaScript still cost, even though they're empty. And so, like right now, I see like an HTTP server. There's dtrace, LTTNG, and counter all in there, right? So it's 3 empty function calls. If I'm not using any of those things from JavaScript, that still costs something. Unifying that so that at most we have one empty function call would be useful. I'm not going to block on that, but we should try and get that in as soon as possible.
Yeah, so that's what I'm saying should be a separate pull request because it is a bigger change to the infrastructure.
Okay, sounds good.
Okay, cool. Well, it sounds like you'll get a good amount of plus ones once some of the other changes happen in the PR. So sweet.
Okay, cool.
One quick question that I have, and I'm asking it now, but it's definitely not going to get resolved until the next TC meeting, which is that do we consider probe additions and subtractions to be part of the API that we are either making forward incompatible or backward incompatible when we change?
Right now, anything related to async wrap definitely isn't. The reason I left it completely like 100% undocumented is because I wanted to be able to iterate on it during the stable release so that people could use it live, right?
Yeah, that makes sense. If we haven't documented the API yet, it's almost like we have. In terms of like, especially the dtrace probe stuff, I know that we had removed some and it caused some breakage, and I think that we even did it inside of patch releases. Are we worried about that kind of stuff going forward as well?
Sorry, it broke up. I missed what we should be worried about.
Sorry, we had removed some dtrace probes and then actually ended up backing out that change because it broke some stuff. Like I think as we go down this path more with abstracting out like the names of the tracing and everything and how you use it, those are probably going to be considered compatibility changes, either forward or backward incompatible, depending.
Yeah, let's save that for a TC meeting.
Okay, cool. Yeah, I'll put it on the. Actually, I have a stability document that I'm working on that's in an issue right now. I'll just add this comment to it, and then when we discuss that in the TC meeting, we can go over it. So. Okay, cool. Now we're all done. Good stuff, you guys. This was great. I will get a PR in for the minutes and everything. And tracing, which is really just to consolidate the work of this group, not to like actually projects under. That's it. Thanks, guys.
Thank you.
Thanks.
Thanks, Seal.
Thanks.
Bye.